Today we're going to be talking about adding and subtracting radicals. So there are 3 rules that you need to remember when we're adding and subtracting radicals. The first one is that you need to simplify all radicals. So this is what we've been doing before when we're taking our larger number under the radical and simplifying it as much as you can. So there's nothing left that can be simplified. Step 2 is to identify radicals with the same index and same radicand. Remember, the index is the tiny number that's outside of the radical, and the radicand is the number under the radical. So you need to make sure that your same index and same radicand are numbers that you can combine. So that'd be, for example, if you'd had the square root of 3 and the square root of 3, you can combine those because they're both square roots of 3. But if you had the square root of 4 and the square root of 3, you can't combine those because 4 and 3 are different numbers under the radicals. These are pretty much like terms when we combine like terms. For number 3, it says for common radicals, you're going to add or subtract the coefficients, and you're going to keep the common radical. So you're not going to add them. So if you have 2 square roots of 3 plus 3 square roots of 3, it's going to be 5 square roots of 3 because you're just adding a number on the outside like we do with like terms. You don't touch what's under the radical. And that's the biggest mistake that I am seeing. So please, please, please be aware that you should not add what's under the radical. Think of it as like an X term. You can't add variables that are not the same. So think of it the same way with our radicals. So our example here, we have negative 2 square roots of 20 minus 2 square roots of 5. So we need to start, step 1 is to simplify all radicals. So 5 is as simple as I can go. There's no perfect squares that will go into 5. However, there is a perfect square that goes into 20, and I know that's 4. So I'm going to go ahead and rewrite this. So I have negative 2 square roots of 4 square roots of 5. Because 4 times 5 is 20. And then I have my minus 2 square roots of 5. Okay, so now I can go ahead and simplify this. I know the square root of 4 is equal to 2. And we can rewrite everything again. Okay, and then I do negative 2 times 2, which I know is negative 4 square roots of 5 minus 2 square roots of 5. So here's the part where it's the like terms. We have both the square root of 5 here. So that is a like term. So all I'm going to do is do negative 4 minus 2. And I know that negative 4 minus 2 is negative 6. And then you just bring over the square root of 5. All right, so let's try a couple more examples. So for number 1, we already have square root of 6 and square root of 6. There are no perfect squares that are going to go into it in order to make this simpler. So what we're going to do is we're going to go ahead and just combine those numbers out front. So we have 3 minus 2, and that is equal to negative 1. And we'll bring over the square root of 6. Now, you typically don't write it in this format. If you have the negative 1, you want to just write it as the negative square root of 6. Okay, and this would be our final answer. So give number 2 a try, and then press play when you're ready. Okay, so if you're ready, we're going to go ahead and try number 2. So we have the square root of 5 and the square root of 5, so I don't have to touch those. I'm just doing 2 plus 2. And 2 plus 2 is 4. And then bring down the square root of 5. Now, number 3, we have 2 different numbers under our radicals, so we need to try and simplify this as much as we can. And I know that when I look at my perfect square list, the biggest perfect square that goes into 63 is 9. And 9 times 7 is 63. Okay, and I know that the square root of 9 is equal to 3. Okay, and then 2 times 3 I know is 6. And at this point, I have 10 plus 6 because they're both square roots of 7. So 10 plus 6 is 16 square roots of 7. Go ahead and try 4. For number 4, you should have simplified our square root of 60 over here to be the square root of 4 and the square root of 15. And then you get negative 6 times 2, square roots of 15, which is negative 12, square roots of 15. Now remember, when you have this, it's basically the same as 1. So it's 1 minus 12 here. And 1 minus 12 is 11. Bring down the square root of 15, not 11 like I just wrote. There we go. All right, for the next one, it's the same idea. You have your square root of 32 and your square root of 18, and both of these can be simplified, so we need to make sure we're doing that. So the square root of 32, the biggest perfect square that goes into it, is 16. Make sure you are finding the largest perfect square that goes into these numbers. Okay, and the largest perfect square that goes into 18 is 9. So I'm going to go ahead and simplify this, and I'm going to cut out a step. I'm not going to write what these simplify to. I'm just going to tell you that, but I'm going to simplify it just one more step. So the square root of 16 is 4, and then 4 times 2 is 8. And then minus the square root of 9 is 3, and then negative 3 times 3 is negative 9. And bring down my square root of 2. And I'm doing 8 minus 9, which is negative 1 square root of 2, which again is just the negative square root of 2. Try 6. Okay, for 6, you're going to go ahead and simplify this to become negative 4 square roots of 4 square roots of 7 plus 4 times the square root of 16, the square root of 7. Go ahead and simplify this. This becomes 2. Negative 4 times 2 is negative 8 square roots of 7. Plus this is 4. 4 times 4 is 16 square roots of 7. And negative 8 plus 16 is a positive 8 square roots of 7. So for number 7, the same idea as these two here. We're just subtracting both terms on this one. So I'm going to go ahead and do negative 4, and then 160, the biggest perfect square that goes into that is 16. And 16 times 10 will get me 160. Minus 2, and then 90, I get 9 and 10. Okay, and then simplify, that's 4. Negative 4 times 4 is negative 16. Square roots of 10. And then this is 3. So negative 2 times 3 is negative 6. Square roots of 10. Now remember, this is negative 16 minus 6, and negative 16 minus 6 is negative 22. And then since they're both square roots of 10, bring that down. Try 8. For 8, you should have gotten the square root of 9 and the square root of 5, and plus 3 times the square root of 49 and 5. Simplify, you get 3 there. 4 times 3 is 12. Simplify here, you get 7. 7 times 3 is 21. Then add 12 and 21, and you get 33 square roots of 5. Okay, so on the back, it's a little bit different. This time, we're going to have terms that are not in common, and that's okay. We need to make sure we're combining our like terms. And the easiest thing to do is to highlight your like terms. I know I say this a lot, but it really, really helps if you identify your like terms. Using a highlighter, using boxes, doing something. So I have my square roots of 10 and my square roots of 6. So I'm going to go ahead and combine my square roots of 10. I have negative 2 minus 2. And I know negative 2 minus 2 is a negative 4. Bring down my square root of 10. And then I only have 1 square root of 6, so I write it there. That's it. So try 10. All right, for 10, you should have had these like terms. You combine your square roots of 7, so 2 plus 4 is 6. Square root of 7, plus bring down the remaining square root. All right, so number 11, this is the same idea, but now involves simplifying first before we combine. It is okay that I don't end up with just one common term. That is totally fine. So I'm going to go ahead and simplify this. The square root of 50, I know the biggest perfect square that goes into that is 25. Okay, so 25 plus 2, and then 18. I know the biggest perfect square that goes into that is 9. And the last one, there's nothing that goes into 3, so I just leave it. So I can go ahead and simplify. This is 5. Negative 3 times 5 is negative 15. Square root of 2. Plus, and then that's a 3. Square root of 2. Minus 3 square roots of 3. So I can go ahead and combine my like terms, which are, I got my 2 greens. So negative 15 plus 3 is negative 12. Square root of 2. And then my minus 3 here, there's no other term that goes with that. So that goes there. So now I'm going to skip these next ones because you're going to do those on your own. And I want to jump down to the bottom where there's the application problems. So we have to figure out the perimeter of the triangle. And to find perimeter, that's when you add up all the sides. So we're going to go ahead and add up all of these. So it'd be 2 square roots of 72 plus 8 square roots of 18 plus 16 square roots of 2. However, I'm going to go ahead and skip a step, and I'm going to start to simplify this before I even write it over here. So I know that for the square root of 72, the square roots that go into that are 36 and 2. All right, and then plus for the 8 square roots of 18, I know the biggest one that goes into that is 9, and that's also 2. And then 16 square roots of 2, that's it. Okay, so I can go ahead and simplify this. This becomes 6. 6 times 2 is 12. that becomes 3. 3 times 8 is 24. Bring down the square root of 2, and then bring down the 16 square roots of 2. And when you add all those up, remember it's just the beginning because it's square root of 2, square root of 2, square root of 2. Perfect, all like terms. 12 plus 24 plus 16, and that'll get you 52 square roots of 2 as your final answer. Now for 18, it's similar process. When you're finding the length and width of a rectangle that's represented by these two expressions, you need to write the expression and then find the perimeter in simplest form. So for the perimeter of a rectangle, you have your length and your length plus your width and your width. Another way to write that is 2 times your length plus 2 times your width. So we're going to use that formula. So we're doing 2 times 2 square roots of 405 plus 2 times 2 square roots of 40, or not, oh man, so sorry. 2 times 9 square roots of 48. All right, so we're going to distribute the 2 last. So we're going to start with what's on the inside. I'm going to go ahead and do the square root of 405, and that's going to get me 2 times the biggest one that goes into that is 81, and then 5, plus 2 times 9 square roots, and the biggest one for 48 is going to be 16, and then 3 left over. Okay, so I can go ahead and simplify this. So I get 2 times 9, which is 18, square roots of 5, and then plus, this is 4, so 9 times 4 is 36, square roots of 3. So now when I'm multiplying, we don't touch this exponent here. We're just multiplying the coefficient term. So I'm doing 2 times 18, which gets me 36, square root of 5. And then 2 times 36 is 72, square root of 3. So my final answer here is 36 square roots of 5 plus 72 square roots of 3, because you cannot simplify this. They are not like terms.